بسم الله الرحمن الرحيم اللهم صل على سيدنا محمد وبارك وسلم عليهم. Peace and blessings upon you all. We were talking about the lex, and now it's time to go into the in deeper and deeper, dig deeper into the lex. So this is a very simple program, we could see here, and we said that a lex program, basically a lex program is actually the lex.l file, whatever I'll call it the second. This is my second.l. okay, it comes to three parts. Firstly is the declaration part, okay, and then we have in the double persons something very important called transition rules, which is not optional, which is need to be there. These guys are optional. And the third thing we have on the bottom is the auxiliary procedures, or we may say the user code. Okay, now this declaration is a very it's optional, and we have few things here which we will discuss. Basically it can include declaration of variables. For example, you have this thing int count. It's typically a C code because we know this lex is gonna convert this into the lex.yy.c, as you could see on the left. Okay, and we could have the declarations. We could have the manifest constants. What a manifest constant is, it is a kind of identifier that is declared to represent a constant. Okay, for example, you may say something like we use it in a C to hash define pi equals to 3.14, for example. So that kind of symbolic constants, we call them the manifest constant. And there may be the file for inclusions like hash include. Okay, and there may be for example definitions of regular expressions. For example, we have a regular expression 0 to 9, and you are defining it to the digit, and similarly you're going to A to Z, cap and small to the letter. So these definitions of regular expressions as well we see in the declaration section. And then we have an option no YY wrap. What this means is, actually, if we don't have this, then we need to include a method of no YY wrap. What it does is, when the lex returns this no YY wrap returns 0 if it was successful, or 1 if it was not successful. In fact, otherwise. Okay, but in this case, when say no YY wrap, we consider that it returns as true. Okay, so no need to put up the YY wrap in here. I will tell that a little bit more later on. And the next thing we have is transition rules. We know them. They are actually kind of pattern and action. So we have here the pattern, that is letter. We have discussed that already, that if it is a letter, then we have letter or digit. Asterisk means many letters or digit. That means we should have the identifier have a first letter should be the letter from A to Z something, and then it could be digit or a letter, not a problem, or an alphabet, not a problem, and many you like. So that is, if this pattern matches, we have a variable called count, and we do it ++, and then in a main we have YY lex. This main is optional, because when we actually give to lex compiler, what it does is it creates a lex.yy.c. okay, even though it's here, if I compile it, it overrides it. This was for the first.l. That's why I told you, if you have the programs and then you keep it in a separate folders. Okay, but here it doesn't matter, so let me overwrite it, no problem. Now if this guy is optional, so if this guy is optional, so where from you get a control, because you have no main. What will happen is there is a default main provided for you in the lex.yy.c. okay, now here we are explicitly saying that we have the main and where we have YY lex. Now this YY lex is important method, which is actually in this lex.yy.c, which runs your that while loop which we discussed last time. We discussed those while loops because I told you this your regular expressions are converted into transition diagrams, and for those types we have these this switch case, and that switch case is inside that while loop. Okay, this while loop basically is which is run by the YYLex, and that is in your lex.yy.c. In this file there will be a method called YYLex which actually executes this code. Okay, and if you see, this is an infinite loop. Okay, this will stay forever there executing unless there is not end of the file or there is some mismatch and failed state. We have a failed state, right? So that means we have to give the if I see the program here, that means when I execute this YYLex, it actually calls in the left yy.c that lex method which runs that while loop for infinitely. So it never comes to here, line number 15, unless we don't have an end of file, okay, or some fail statement. Okay, so if you want to run it this time, we'll try to use command prompt. Okay, let me do it where command. So we are actually in the lex file, that is exactly the same folder where my file is. This Flex does it for me in Edit Plus. Then first thing I will say is lex and the file name. So we are saying that hey, this is the lex. Okay, then we have the file name. What is the file name? It is second.l. okay, 2nd.l. okay. Before doing this, I would like to actually delete this file so that we see that it's being created, right? So let me delete this. Say yes, no problem. Come to the command prompt. Where is that? This one, and give it a go. Now what will happen by this is it will compile this second.l, the lex file, into the. It's not coming, so you can see. Obviously, refresh. Here, where is the refresh? Here is the F5. Oh, this is lex.yy.c is being created. Now this is the lex.yy.c or C file, compiled file of the second.l, right? Now after we compiled it to the lex.yy.c, we know in this there will be a method called YYLex which we are calling here, right? We should run that infinite while loop. So before before executing, we need to first build it. So how we build it, we say for example gc/cc, something like that. So we say for example gcc, and then we have the should we say file name or should we say lex, because now this is the actual thing. So we should say here lex.yy.c. if I do this, that means build it. Now it always build it to the a.out which we talked last time, right? So we said that we had a source file, we give the lex which creates the lex.yy.c. Then with this lex.yy.c is given to the C compiler. For example, this is here, and it creates a.out. But a.out is actually the lexical analyzer which sees our inputs. So if we execute that, it sees our inputs, and according to the patterns we have written here, it does the job. Okay, picture is getting completed. Okay. Before doing this, okay, give it a go, and I will show the diagram. I would like to show the diagram again. Basically, let it do its job first. If it doesn't have errors, okay. Oh, it seems there are no errors. Now, if you do one thing here, if you say refresh, now a.exe is coming up, as you could see. Now you have to run the A. Simply say a.exe or simply run the A. Now it is executing. Now what will happen by this is, oh, my antivirus is actually trying to see things. Okay, no problem. Okay, my antivirus declared it to be save file. Now what's happening here is this while is being called, okay, and when this while is being called, what will happen is it will execute that while loop, which will try to scan the inputs and try to run according to those inputs the transition diagrams and the code for transition diagrams, and stay in that while loop forever, right? So it will stay forever unless that fail method is not called, or for example we have end of the file statement here, then it will return back from this while else. Or we could terminate it. While else also, we have a method also to terminate it. We can do that later on as well. But here, for example, I say, for example, some actual variable name. For example, I say Junaid, and then I say 786. This is the exact variable name, right? Where we have a letter up front, then any many letters or digits, no problem whatsoever. Now, if I say error, it says okay, no problem. It's working fine. Okay. Then if I have only digits, for example, it's stopping it back, because what will happen is Lex does what? If it doesn't match, your pattern what you have written here, so it will stop it back to the std out. Okay, so it's showing me back. But this guy has matched, so for this guy we have the action. What is the action? That is count plus plus. So count was initially 0, now it has become 1, and if I continue, I should have kept it here equals to 0, but no problem. Now let us see what will happen. Now you carry on with this. Say for example another perfect, say for example IQBAL 88. Now this is again a good variable name, identifier, no problem, and go on. But it's staying in that while loop. As you could see, it's waiting for the input. It is staying in the while loop and asking for our characters to enter here. Okay, like that we said here. I'll show you in a minute. While we say here C equals to next char, so this thing is waiting again and again. Okay, and it's staying here unless I don't say Control Z or something, means end of the file. Okay, then say end of the file. It goes back and says, hey, we had two identifiers, so one is here and one is here. The rest of the guys in between were not, because C++ count plus plus you did it, and that has what is happening. Control Z is it gets back from the it gets back from the, what is that, Lex method, and comes here on line 15 and executes this guy, which says that the number of identifiers equals this much, and then returns back. Okay. So this is one of the kind of programs we had, which is a little bit clearer. Okay. Sometimes we may have a lot of technicalities here. We may try another program to see different things. One more thing I may add here is that if I execute the same commands again, firstly the Lex, then I'm compiling again to my lex.y.c, it will be overwritten. Then I say gcc. When I say gcc, then I said what else? Then I need to give the file name. Which file name? The C file name. That is always lex.yy.c. Okay. Then I do a little bit of thing, that I space and I say hyphen and then I say O. That means output, that give me the output file a particular name, not that A which we had by default, which is always coming there. I say give it a different name. Okay, maybe I call it the second as well, or maybe something else. Okay, maybe I will say call it scanner, SCANER, or something else, or maybe the same name. Now what will happen by that is it will compile it. Okay, and we have the executable file, refresh it, called scanner.exe. Is it? So what will happen by that is, now actually in this case the a.exe and scanner.exe is exactly same. Only thing is I have renamed this file to the scanner. Now you run the scanner, it will do the same job it was doing. Okay, it's waiting for the input. Actually my antivirus is trying to see whether it's safe or not. Let me close that. It's safe, I know it. So let me put up something like JJ, KK, maybe J, and let me put a J star, J and ampersand. Okay, now if you look at it here, what has happened is the J is the identifier. It may have taken that, but after that the ampersand, that's not, it is put up here, right? It has stuffed it back, because anything which is mismatch is going to be stuffed to the output, and which is match, particular action will be triggered. Okay, what is that in case of action? That is the plus plus, count plus plus. So if I give it a control Z here, it will be 3 identifiers are 3, because JJ, KK and J, right? Okay, this is our second program, right? Let's see what we are doing here. We are saying that this is the same as we have std inclusion files, and then we got vowels and consonants. One important point which I need to add up here is that this special section of declaration where we have this kind of percent and brace, and then percent and the closing brace after that, and it is like this. Whatever you write here is copied verbatim into this lex.y.c. What I will say is whatever you write here, it's copied exactly the same way into this without any changes. So you are writing here exactly the C code, and same happens with the user code here, right? Whatever you write here, these two guys are copied same to same. Okay, they are put up from here into this file. Okay. Now what we are trying to say is that if in the rule section is that if you got a E, I, O, U, that means if you have the characters like A or E or I or O, that's equal of saying A pipe, E pipe, I pipe, O pipe, and so on. That means if any of these characters is met, you do one thing, you add up the vowels, and if anything other than that is there, then you do one thing, you say the consonants plus plus. Okay, then when you're done, you actually print out how many vowels and how many consonants are there, simple as it is. So let me run a command, and what's first thing to be done is lex, and the file name is second, the same file name. Actually I wrote that file, and then we say gcc, what is to be done here is lex dot yy dot c, then output option, I call this as a second. Okay, let me call it a second, 2nd. Okay, now we'll have a second.exe here in a moment. I say refresh, second.exe has come up. So where is my command prompt gone? Here it is, and then I run it, call the second. Okay, again my antivirus is trying to chuck it. Let me close that. Okay, it's saying enter the string. Now I should have said backslash n, I forgot it. Anyways, let my string be, let me put the enter. Okay, let my string is AB. Okay, what about that? Let me string is JUNAID. Okay, and then I say Control Z, and I say okay. Now it's saying number of vowels 4 and number of consonants 4, because we are talking here about the single characters, so there is no conflict whatsoever. So single character A, it's a vowel, then U, A, I, and B, J, N, D, 4 equally, so it's working fine. Okay, sometimes when we have a conflict, okay, we try to see another program where we have a conflict, and I will try to see how our lex actually resolves that. Let us change a bit this guy. Maybe I call it let me delete these two, and even delete these two guys. And I'm saying if there is, say for example, TEACHER, or I should say or I have a tutor, TUTOR, or I may have a professor, PROF, or something else, whatever you like, just for teaching you the, actually I'm trying to say kind of conflict resolution. Then I say prunf, what to say, backslash my profession, I don't know what, call it like that, okay, backslash n. And if you have terminator, and if you have say for example same A to Z, if it was A to Z, or simply capital A to capital Z, but I will add the plus here. That means at least one or many, means I'm not looking for a single character, I'm looking for maybe a word. Even though there is a single character, at least one character could be there, or actually a word. I'm talking about many. Then I'm gonna say copy this thing, okay, and maybe I will say it's not my profession. I'm gonna say not my profession, right? Okay. Now I'm not looking for a single character. Have I put the space here? Let me make it sure that I put a space. Okay. But I'm saying if the input word is a teacher, exactly the teacher, like TCAPS, tutor, and professor or something, I'll say, hey, it's my profession. And if it's something else, at least one alphabet or more than that, to make up a word actually, I'm saying not my profession, okay? Then I say enter the string, for example, here like this, backslash n. Last time it was a creating problem, and so on. I think it's okay. Let me give it a go. Let me say one thing. I say go to the tools, I say lex file compile, I say lex file build. Okay, it's not coming up yet, sorry. Tools, lex file build. Even though it has an errors, it will not show it yet because it just makes it a C file. Now when we compile the C file, if there are some errors, it will show them up, okay. Lex build. Hopefully it will not have any errors. Okay, no errors at all. Tools, let me exit directly now, whatever. Okay, it's coming up. Enter the string, say for example I say teacher, okay, it is saying my profession. Now on this I'll come up here. When I say teacher, for example, here, and I say my profession, okay, teacher is exactly matching this criteria, this pattern, so it's printing up my profession. But what about this? Isn't it matching as well this guy? Because I'm saying any character from either small or capital, and many as you like, say plus closure there, isn't it matching as well? Yeah, it is matching. So what happens here is the Lex does two things. One is if it matches the one pattern, that means it's executing one transition diagram perfectly, then it doesn't go for other transition diagrams. So one thing is that. Second thing sometimes also happens that that it goes for the longer match. Okay, if it's, say for example, if it is like TEA here, okay, and in this case is coming teacher. If I say upfront this and then this, okay, then it goes for the longer case. It goes for the longer case. It try to see the full alphabet, okay, full word. Okay, you try to see full word and figure it out. Oh yeah, it is. Say, let me give one example of that. Just first, let me complete this. I'm saying, say for example, teacher, and I may say tutor. Okay, if I say TUTOR with small t, it's saying not repression because it's not matching my pattern. Okay, That's it. If I say something else, maybe he's a doctor, then it's not my profession at all, and simply exit from the input. Let me give the vice versa example as well. We can do it in the same program. Let me execute the same. When I said that I had a, for example, tutor, that is my profession, that's matching the pattern. What about if I change it, say tutoring, whatever, I'm saying tutoring. Now it has identified tutor. Okay, if we see here in this case the tutor is matching. Okay, it must be running this context, this transition diagram or code of transition diagram where the tutor is matching, but it doesn't stop. It goes for the longer matches. Okay, that's what Lex does. So otherwise it would have said, okay, tutor, it says match. Maybe it would have said tutor, okay, tutor is the match, and then it would have printed up the my profession, and then ing would have been a second token. A lexeme has been identified. The second lexeme, this is the second lexeme, ing, which would have triggered this action, which is the at least one alphabetic characters, alphabetic strings. Okay, with at least one character. This is what it is. So, but what it does is it goes for the longer match. That's also called as the maximal munch in some books, which is maximal munch. So, so what our Lex is doing is Lex patterns only match a given input character or a string only once. So once it is matched, it's not going to match for the other guys. For example, saying tutor, it's matched here. It will not be chucked to the another with the another pattern if it is matched. But in this case, the rule second will come up, which says for the longest possible match for the current input, it goes for that. So maximal munch, what I'm talking about. So that is it just doesn't stop when you say tutor and there is something else. It try to execute other transition diagrams, try to figure out if they are fitting in for that or not. If they are fitting in, it will say have I executed? I haven't. So if I say enter, it says not my profession, because it's matching now this guy, the rule second. Okay. Hopefully these programs are helping, and hopefully we see more programs in the further videos. Until then, masalama. Okay, now this is another program where we learn actually a few more things, especially this YYLang. It is what is this YYLang? Is actually basically we have YY text which holds the lexeme, and YYLang actually gives what's the length of that word. Okay. So if we I will explain it. I'm saying firstly the definitions. Where is the word? I say word is something which is not space, not tab, not new line, not comma, or these guys. Okay, and plus means one or many of that. Okay, so it should not have these. Other than them, whatever there is, that I consider word. Then if there is a backslash n, I consider that EOL, and if there is a blank space, I call it a blank. Okay, then I got my inclusions, and then I say some variables like C, character count, word count, space, and line number, lines, how many lines we have. Okay, now then in my rule section I say if I find the word, that's this guy, I will do W++, and from them that word I will see what is the length, length of that word, and I add to the C to give me the character count, simple as it is. And if I have the blank, then I'm gonna say a space plus plus, and if I'm gonna end of line, say line plus plus, and if I got a dot, even somewhere I have a dot, okay, full stop, then I say that's character plus plus. Okay, that's not considered to be my word, but that's my character. Okay, then in the main I'm saying few things, like I got a variable I for a loop, and then I am having here in the main I you know, command line arguments, you know, those things from the C language. This holds the how many arguments we have, and this holds the actual arguments that we have. The first one will be the file name, and the second one will be whatever argument we pass, and we are going to pass the file from which we're going to scan. So we're not going to give the inputs from the keyboard or stdin, which is the default input for the YYLX, but we will get the input from a file. That's why we need what's called as YYIn. It changes the default you know, thing of the YYLX, which is to get the input from the standard input device. But YYIn is a pointer which points to the file from which you wanna open. Okay, and I'm saying YYIn, and I'm opening a file which is in a read mode, whose name is in the argument 1, argv1. That means in the character array, the second argument, the second element. So that means when I run this program, you should be knowing, before this you should be knowing the command line arguments and how to execute that, because that's the C stuff. If you don't know, watch my video on command line arguments on my channel. And I'm saying the first one in this will be the file name, which is this is the third. It's the third, called the third.l. So it will be third.l. The second box of the array will hold the file name, which I will actually pass at the runtime. Okay, when I execute this program. Okay, so that's why YYIn is doing here, that is pointing to the second argv1, that is second box of this character array, and I'm opening that file in a read mode. Okay, so what I'm technically telling is so what I'm saying is argv is in character array. Okay, the first box and next box, so let me make it a little bigger. Say from this, the first box which will have the third.l in it, and the second box is I will try to run a file. Say, let me see in this folder if there is a file. .text some file. Yeah, we have first.text already. Yeah, so that will be here, first.text. So how are you going to execute it? Say for example, when you run it, you are telling third at the command prompt, then you pass the arguments, that is first.text to it. So this will go here, and we are saying that this is argv of 1. Arg is missing, gre of 1. That means I'm talking of this guy. So I'm saying open this file in a read mode, and we have a pointer called this one. YYIn is pointing to that. So now YYLX will not take the input from the default input device, but it will take the input from that file, and then it will scan it until we don't have an end of file statement, and then it will do this thing. When it finds the word, it will do W++ and cut characters out of it, and blanks, S++, end of line, L++, and C++. If there is a dot, character plus, and at the end when it returns, because it finds end of the file, so it will return the YY wrap we have. No YY wrap means that it will always return true. So it will come back, and it will come here, wherein it will say how many characters we have and how many words we have. Okay, I should also say the spaces and lines as well, right? Okay, I will add those things also. I forgot. Here only number of characters I said, and I'm saying number of words, that is CW. Let me give it a let me make it a different printf, or could have done the same. It's running out of my screen. Let me copy this and paste it. Copy and paste, Control V. So I'm saying number of characters and words already there. Then I have the number of lines. Maybe I put up the \n's as well, so that there will be no problem. Number of characters, words I already had. The number of lines, percentage D backslash n, okay, no problem, and number of, after that, number of, what is left out? We have the words, characters, and lines, what is the spaces? Yeah, spaces, number of spaces, spaces, spaces is equal to percentage D. And now I need to say, for example, what is my line? That is L, right? For the lines I got a L, and for the spaces I got the S. Okay, okay. Now it will give me all the things, and I will save it, and I try to run it. I will use the command prompt, open command. And now the first thing to be do is the flex, and file name is third.l. If it has no problems, okay, then I say gcc let's.yy.c, and I will rename it output file, not as an A default, but maybe I call it the third. Okay, now there is an error. Oh, I said 0. I should say O as an output. Oh, I'm saying again 0, sorry. Whatever. Here we go. Yeah, it's working fine. I say third. When I run it, I'm passing the name of the file, that is first.txt. You can say whatever file you have in the same folder, and this third actually will go into the argument first, and argument 0 and argv1 will hold this, and then yn here, it will point to this file and start scanning from this, okay, and scan it until we don't have an end of file statement, end of file. Okay, if you could see argc equals 2, that is we have 2 arguments in here. If you see here, argc holds how many arguments we have, how many character in this character array, how many arguments were they passed at the time of calling. This is 2. First one will be arg of 0 will hold the file name, that is third, and arg of it's not arg, it's argv. I have written here arg, that's not a problem. I've written arg, whatever it specifies this thing. Of 1 equals to first.txt, okay, that is whatever I have passed here, okay. And now in the file which it scanned, the number of characters were 136, number of words were 24, number of lines were 13, and number of spaces were 12. So it's telling me exactly everything, whatever in that file is. So in this program we learned how to open a file, and we learned couple of one of the pointers were lex, and we also learned the length, how to get the length of a particular word. That is the why we did that. That is the YYLen here, okay. And there's also one more thing, that for YYText, which actually holds that lexeme. So if you print YYText, it will if it sees the word and you print here you say print of YYText, it will tell you exactly the word, okay. Okay. Now what I did here is I'm saying that after this word, I'm saying printf \n percentage d percentage. This is for the length, YYLen, and this is the YYText which I was talking about, the lexeme. When it identifies the lexeme, it is gonna print that YYText. So it will count whatever, but whenever it finds the lexeme, the word, okay, then it also prints the length of that word and also the YYText, right? So what I do is I give it a go. I say lex, then I say this thing, then I try to run it, giving the file name, and now you could see it's telling me that the first lexeme identifies these guys, and the 2 count is 2, and YYText holds that lexeme. Okay, YYText is telling me how, and giving also the YYLen is giving how much length is this, 1 2 3 4 5 6 7 equals 1 0 and this and so on. And at the end, when it comes out of the flex function, it tells me the number of characters, number of words, number of lines, number of spaces, and so on. Okay.